Jai Hind students. In the complex video lecture series, today we are going to discuss the topic amplitude modulation, which is from the first unit of analog and digital communication subject, that is for the 5th semester electrical and electronics engineering branch. So that topic is very important as far as the syllabus of the this analog and digital communication for AKTU is concerned, as amplitude modulation is the first part of this topic of this subject. So in this particular today's lecture, we are going to concentrate on the content related to the analog modulation introduction, then various form of AM and then frequency spectrum. So before starting that about the modulation part, amplitude modulation part, first of all I want to tell you that what is modulation. Basically that is a low frequency message signal, and as far as you know that when frequency of any signal is low, then the signal cannot travel to the long distance because of its low power. To increase that power, this modulation concept is going to be used, and in this modulation concept we are using a high frequency carrier signal to modulate this low frequency message signal. And when we superimpose this low frequency message signal on this high frequency carrier signal, we will get a modulated signal, and that modulated signal having a higher frequency, and that higher frequency can easily can help to travel the signal to the distant places. So when we are talking about this modulation, there are basically two types of modulation. First one is analog modulation and second one is digital modulation. This whole syllabus is related to these two types of communication, in which your first and second unit are related to analog modulation, whether the third and fourth unit is related to the digital modulation. In the first unit, the analog modulation having two parts, and that part are basically AM and AM. This AM denotes the amplitude modulation, but this AM is for angle modulation. Then how we are going to discuss this point? Actually, whenever you are taking any expression for a signal, let the signal message signal is xt is equal to am cos omega mt. In this signal, you know that this am is amplitude of the message signal, this cos omega is the angular frequency of the message signal, and that cos omega mt denotes the phase of the this message signal. So whenever we are going to do that modulation part, we are going to change the carrier, means there is another signal that is CT, and that is AC cos omega CT. In this, AC is the amplitude of the carrier and omega C is the angular frequency of the carrier. So in the process of modulation, we are going to change either the amplitude of the carrier or angle of the carrier. So if we are changing the amplitude of the carrier, then it will become amplitude modulation, or we are going to change or modulate the carrier frequency or phase as per the instantaneous value of the message signal, then this angle modulation came into the picture. So by this process, we are going to start this amplitude modulation part. So here you can see that in amplitude modulation, we have a carrier wave. This carrier wave have a high frequency value, whether the sinusoidal modulating signal or message signal having the low frequency. So when we superimpose this sinusoidal message signal on the carrier wave, we will get this amplitude modulated signal. So in this process, if you are going to define this amplitude modulation, you can define that when we are changing the amplitude of high frequency carrier signal as per the instantaneous value of the low frequency message signal, and the amplitude and phase of the carrier will be kept constant, then that process is known as amplitude modulation. So this is about the basic introduction of amplitude modulation, and here you can see that in this resultant amplitude modulated signal, you can see that only amplitude is varying. Whether the frequency is same, you can see here the number of cycle in per unit time is equal in both the signals, and also the phase angle is also the same in the both the signal. So here you can see that only amplitude is changing, that's why it is known as amplitude modulation. Now to discuss the various type of amplitude modulation, first of all we have to derive the expression for the amplitude modulation, and how it is going to be done you can see here. So if we are taking a message signal, that message signal may be mt is equal to am cos omega mt. So as per this equation you can draw this waveform. Here you can see that am is the magnitude of the signal, and that part is denoting the frequency and time, because here we are using the time on this axis. So as per the time cycle in per unit time, you can calculate the frequency and also the phase information. So now here you can see that the second part is for the modulation is carrier, that Ct is equal to AC cos omega Ct. So here you can see that AC is the amplitude of the carrier signal. So in this AC part, this is the carrier. Now as per the amplitude modulation formula, the resultant ST, yani ki the amplitude modulated waveform is denoted by, as I told you as per the definition of AM, amplitude of the carrier is going to be changed, not the frequency or phase. That's why you can write the amplitude of the carrier is AC plus the instantaneous value of the message, means mt, plus mt, and cos omega Ct is same as this, because you are not going to change the frequency or the phase. So this is the amplitude modulated waveform. As per this you can draw this diagram, how that this is the part or this is the point where the value is AC. On this AC value, whether this message signal is going to superimpose, whether that is going to be add into the, or that is going to be subtract from the signal. So in the positive cycle you can mark here as the positive waveform, but in the negative part you are getting this minimum amplitude values by plotting the 180 degree shifted of version of this message signal, because this is in the negative quadrant. So this is the resultant amplitude modulated signal as per the amplitude modulation definition. So now as per this part, there are 4 types of amplitude modulated signals, and that are, that first one is conventional amplitude modulation or double sideband full carrier. Second one is double sideband suppressed carrier, single sideband modulation, and vestigial sideband modulation. These are the 4 types of the amplitude modulation. So in this, how you are going to decide? Basically, when we are going to create the final equation of this amplitude modulated waveform, you will get 3 parts. That part are, one is carrier, second one is lower sideband, third one is upper sideband. How you are going to create this? You can see here. So in this, first of all, take a carrier signal. Ct is equal to AC cos 2 pi fct, where 2 pi fct is equal to omega c, because this is the frequency, whether this omega c is the angular frequency. Similarly, for the message signal we are taking am cos omega mt, where omega m is equal to 2 pi fm. This is the 2 signals. So this am and omega m and fm and AC, omega c and fc, these are going to be decided by these 2 equations. Now as per the amplitude modulation equation, you will get this equation, and that equation is, am equation is AC plus mt cos omega ct, where AC plus mt is the amplitude of modulated waveform called as envelope. In this diagram you can see that this is the envelope that is forming here, and that envelope is forming by this part only, AC plus MT, because as per the definition of amplitude modulation, that defines amplitude modulation in which the carrier amplitude is going to be vary as per the instantaneous value of the message signal. So here we are taking that part. Now for the further derivation, you are going to put that MT value in the equation. MT value is AM cos omega MT, you are going to put here, and we will get AC cos omega CT, AM cos omega MT cos omega CT. By applying the cos A cos B formula, we are here putting 1 by 2 2, and as cos A cos B, that formula is cos A plus B plus cos A minus B, and in the last we are going to get that equation AC cos omega CT, AM by 2 AC cos omega C plus omega M cos omega C minus omega M T. So this particular equation is here denoting three parts, and before that we are here using one point that that AM by AC, when we are multiplying the both upper and lower part with AC, we are getting this AM by AC, and that AM by AC is denoted by MA, that is the modulation index of AM. What is the significance of this? That we will discuss in the next slide. So here we are going to put this AM by AC is equal to AC MA by 2. So now in this final equation of AM, you can see here that there are three parts. First one is AC cos omega CT, means that is totally equal to the carrier part, means this part is carrier. Now second part is cos omega C plus omega M, means that part is known as the upper side band, and its frequency is omega C plus omega M. Similarly, the third part is denoting the lower side band, and its frequency is omega C minus omega M. Or this is going to give us the basic AM equation. So here you can here see that this part is carrier, this part is upper sideband, and this part is lower sideband. Here when you discuss this result, you can see here that this part is only getting the carrier part, whether this sideband part are actually having the message information, means these sideband magnitude actually having the message. So also the another point is these both sidebands are replica to each other. You can see here the both amplitude is same, only the frequency is different. So you can understand here one point, that when we are talking about the complete power of this waveform, a much part of the signal is going to be acquired by this carrier part, which is actually not taking any type of message to the distant place, and the part of signal which is actually taking the message to the distant place are upper sideband and lower sideband, but they both are duplicate. As per these parts, we can decide the first three types of the modulation, and you can see that in the conventional amplitude modulation, that is this equation. It means in the conventional AM waveform, you are having three parts: carrier, upper sideband, and lower sideband. But you know that carrier is actually the unnecessary part of this equation, and unnecessarily it is consuming the power. So to improve the power content of the AM, we are going to suppress this part, and by this process we will get double sideband suppress carrier. That is the second part of the second type of the amplitude modulation. Now in the double sideband suppressed carrier, actually we are having lower sideband plus upper sideband, but again you can see that the both sidebands are carrying the same information two times, means again if we are going to transfer only one sideband, then we will get a cut in the power dissipation or the power contained of the AM. So the third type is coming into the picture, and that is SSB, single sideband. Means in single sideband actually we are taking either the upper sideband or the lower sideband. The vestigial sideband is the another type of the amplitude modulation, in which we are taking either the upper sideband with some part of the lower sideband or lower sideband with some part of the upper sideband. Means in the vestigial sideband, the one sideband is complete, but other sideband is in some kind of fractional part only present in the final AM signal. So these are the four types of the amplitude modulation signal. Now, as per the frequency spectrum is concerned of the AM, here you can see that this is the AC cos 2 pi FCT part, this is FC plus FM, and this is FC minus FM. So when we are going to plot this by taking Fourier transform of this equation, we will get this equation, and this Fourier transform will tell us that frequency spectrum of AM signal means double sideband full carrier signal. Actually, we are having two amplitudes that are AC by 2 and M AC by 4, and that comes from these part, where M is equal to modulation index, which I take MA in the previous one. So here you can see that this is the carrier part, which is going to denote by the plus FC or minus FC. You can see here, and then the lower sideband and upper sideband. How we are going to decide? Then FC minus FM is the lower sideband, FC plus FM is the upper sideband, and the amplitude of these part are defined as per this. You can see here that is AC by M, AC by MAC by 4. So these two are the part of the frequency spectrum. So they are now sideband. So when we are talking about the sideband, bandwidth of the AM, you can see here that in AM equation we are having three frequencies that are omega C plus omega M, omega C minus omega M, or we can see that FC plus FM or FC minus FM. Means in the frequency part, we are, as per the Fourier transform, we are having two maximum and minimum frequency. The maximum frequency is FC plus FM, whether the minimum frequency is FC minus FM. So to find out the bandwidth, we are going to subtract from first one to second one, and that is FC plus FM minus FC minus FM, and we will get the twice of FM, and that is the bandwidth of AM. So similarly, we are going to discuss about the modulation index. So basically, whenever we want to know the amount of modulation, that is basically define that how much modulation take place, then we use this modulation index term, and that modulation index term where sometimes we use MA for this, sometimes we use mu, and that is actually the ratio of the amplitude modulation, message signal amplitude and the carrier signal amplitude. So this is the modulation index, and when we want to know that percentage modulation, the percentage, when we multiply this modulation index value with the 100, we will get the percentage modulation. So this is the complete part of the modulation index. So similarly, this modulation index, when we discuss this waveform part, you can also find out that in the waveform part we will get that two amplitudes. This one is the maximum amplitude, whether this one is the minimum amplitude, and we will get the modulation index by the formula that mu is equal to A maximum minus A minimum upon A maximum plus A minimum. And as per this modulation index, there are three possibilities. That possibilities are whether this mu, that is Vm by Vc or Am by Ac, is greater than 1. It means when Am is greater than AC, then we will get the over modulation case. When AM is less than AC, we will get the under modulation case, and when AM is equal to AC, we will get the critical or ideal modulation waveform. So this modulation index actually define the amount of modulation that is present in the modulated AM output, and this all is going to decide that how we can discuss this modulation index or AM. So in university examination, when we are taking about this first unit of this syllabus, you can easily understand this topic, and this is the question that frequently asked in the university examination of KE 058, that is analog and digital modulation. So that is completed for that AM part. Also the power of AM, that is in term of the complete part, and that power is basically related to the power content of the AM, in which we are having the total power is equal to power of sideband with the power of carrier, and by adding those two part, we will get the power of AM, that is AC square by 2R, that is for the carrier, that is for the upper sideband, and that is the lower sideband. Here you can see that both upper sideband and lower sideband are carrying the same information. That's why the amount of power is also equal. So we will get this, and the total power, the equation as per the modulation index, that is PT is equal to PC 1 plus mu square by 2. So this is the power of the AM, and as per the power of AM, we can also find out the efficiency of AM. And in the efficiency, when we are going to decide that the amount of useful message present in the AM wave is expressed in terms of the transmission efficiency, and that is defined by the neta is equal to sideband upon total power. So sideband are lower sideband, upper sideband, P total. These are the value of the sideband's power, and this is the P total. By solving this, we will get percentage efficiency is equal to MA square by 2 upon 2 plus MA square into 100. That MA square is equally denoting the modulation index. So this is the efficiency of AM for this lecture. Thank you so much. In the next lecture, we will discuss about angle modulation.